Welcome back. In this video, we're going to review how to solve absolute value equations. So to do this, we want to first review what an absolute value is. So we have a number line here, and this is 0 on the number line. And so an absolute value, by definition, is the distance a number is from 0 on the number line. For instance, we have a number over here, we'll call it A. The distance between 0 and A is defined as the absolute value of A. It also turns out to be the same for any other number, even the opposite. So the opposite, the absolute value of the opposite of A is this distance here. And those are equivalent to each other. So the idea is, if you take an absolute value of any number x, it will equal the positive, so if you have the absolute value of some number equaling a, call a any constant, that means that the value of x can either equal the opposite of a, or the value of x can equal positive a, because negative a and a have the same absolute values. So we'll use this fact to solve some equations here. Okay, so let's do some examples here. So let's start off with like the absolute value of x equals 7. So when we solve absolute value equations, we want to think about what values or values give me an absolute value of 7, or what value or values are 7 units from 0 on the number line. Well, that would be plus 7 or negative 7. So we let the inside expression, we say that can either equal the opposite of 7 or it can equal 7. And so these two values would make that absolute value true. And so our answers would be negative 7, comma 7. Okay, let's do another one. So let's do the absolute value of x equals 419. And so again, because there's only one value, okay, we're equaling 419. We ask ourselves what number or numbers are 419 units from 0 on the number line. That would be negative 419 and 419. So x can either equal negative 419 or it can equal positive 419. Okay, so let's give you an example. So absolute value of 17.6. So once you pause the video and write down what you believe the solution or solutions to that absolute value equation will be. Okay, so in this problem, just like the previous two, what number or numbers are 17.6 units from 0 on the number line? That would be negative 17.6 and positive 17.6. So x is going to equal either negative 17.6 or positive 17.6. And so our solutions would be x is negative 17.6 and 17.6. Those are pretty simple examples. So let's move on to a little bit more complicated ones. So what if I had the absolute value of x minus 6 equals 14? So we know that's an absolute value sign. Okay, so even though I have an expression or more than one term inside the absolute value, my process doesn't change. So I ask myself, first off, what number or numbers have an absolute value of 14? Again, that is, what number or numbers are 14 units from 0 on the number line? Well, that would be 14 and negative 14. So what we want is you want to determine what values of x cause the expression inside the absolute value to equal those values. So we set up our two equations. We say that, well, if the result of x minus 6 gives me negative 14, that'll work out, that'll be true. Or if the absolute value of 6 equals positive 14, that'll also be true. That'll give me a true statement. And so we're going to solve these equations. One thing I want us to note is that, hey, on each equation, the left-hand side are the same exact thing. So whatever I do algebraically to solve for x on the left equation, I'll do the same exact thing on the right. So we often solve these equations simultaneously, so at the same time. So on the right-hand side, what do I do to get x by itself? Well, I gotta move that negative 6 over by adding it. So what is negative 14 plus 6? Well, that's negative 8. And then we'll do the same thing on the right equation. We'll add 6 to 14. That gives me 20. And so my answers are x is either negative 8 or positive 20. Let's try another one. X plus 9, the absolute value of x plus 9 equals 27. So the same idea, we want that expression inside the absolute values to equal 27 or be a number who's 27 units away from 0. So that would be negative 27 and 27. So we set up equations. As long as x plus 9 equals negative 27, that's going to work for us. Or if x plus 9 equals positive 27, that's going to work for us. Then we'll set them equal and we'll solve them simultaneously. So it looks like in both equations, we're going to move that plus 9 away. To do that, we're going to subtract it. So we're going to subtract 9 from negative 27. That gives me negative 36. We're going to subtract 9 from positive 27. That's going to give me 18. And so in this case, x will be either negative 36 or 18.
On medium side.
Okay, so you try this one. Absolute value of x minus 10 equals 64. So pause the video and see if you can get that one. Okay, so what number or numbers are 64 units from 0 on the number line? That would be negative 64 and 64. So we want x minus 10 to equal either negative 64, or we want x minus 10 to equal positive 64. So in both cases, we'll add 10 to both sides. So in the left equation, we'll get negative 54. In the right equation, we'll get positive 74. So those are our solutions. Okay, we'll do one more kind of these problems. So let's look at this problem. 3x minus 4 equals 6. Okay, so we want the same idea, but now we got a little bit more complicated, complex thing inside the absolute value, which is fine. So again, the process does not change. We ask ourselves what number or numbers are 6 units from 0 on their number line. Well, that would be 6 and negative 6. We let 3x minus 4 equal negative 6, or we let 3x minus 4 equal positive 6. And so these will be two-step equations. So the first thing we'll do in both equations is you will add that 4 over. So when I add 4 to negative 6, I get negative 2. When I add 4 to 6, I get 10. And then I'm going to divide by 3. So I get negative 2/3. And I get 10/3. Those are repeating decimals. So we do not want to round them or write them as decimals. We just want our answers in fraction form. So our answers are negative 2/3 and positive 10/3. Let's try another one. So how about the absolute value of 5x plus 2 equals 17. So what number or numbers are 17 units away from 0? That'll be negative 17 and 17. So we're going to let 5x plus 2 equal both of those values in our separate equations. Okay, and so now we'll solve simultaneously. So in each first step is to subtract 2 from both sides in each equation. So we'll get 5x equals on the left, negative 17 minus 2 is negative 19. On the right, 17 minus 2 is 15. We'll divide both by 5, so we get negative 19 over 5 is negative 19 fifths. That is a nice decimal, but I'd leave it as fraction. 15 divided by 5 is 3. And so our answers are x can be negative 19 over 5 or positive 3. Okay, so I'm going to give you one last one to try here. So the absolute value, oh, that's a really big absolute value. Let's erase that and try that again. So we want the absolute value of 4x minus 7. We'll let that equal 33. So once you pause the video and see if you can work that one out. Okay, so last one, so you've got this right. So we're going to set up our equation. So it's going to be 4x minus 7 can equal negative 33, or 4x minus 7 can equal positive 33. So we'll add 7 to both sides. So on the left, 4x is going to be negative 33 plus 7. Let's do a calculating in that one. Get negative 26 there. Then over here, 33 plus 7 is 40. So now we're going to divide both sides by 4. So 26 divided by 4, that actually reduces to be negative 13 halves. And over here, 40 divided by 4 is 10. So our answers are negative 13 halves and positive 10. So hopefully this video has given you a little insight into solving some pretty introductory absolute value equations. If you found this video helpful, please like and subscribe to this video on my channel. Thanks for your time.